Well, hello again. It's great to have you back. In 3.5, our goal is to graph lines in a coordinate plane given the equations of those lines. Also, to be able to do the converse, write equations of lines that are given their graphs in a coordinate plane. So we want to graph lines and write equations. This is basically a review from Algebra 1. Let's see how much you remember. There's three different forms for linear equations. Slope-intercept form is y equals mx plus b. Point-slope form is y minus y sub 1 equals m times x minus x sub 1. And standard form is capital A times x plus capital B times y equals capital C. Let's look at some similarities in the first two forms. Those are the forms that we use most frequently to graph. In the first one, we have an m. It's a coefficient of the x. The m is our slope. That's very similar to in point-slope form. Notice both of these have slope in their names because both of these tell us what the slope is just by looking at the equation. In slope-intercept form, the b tells us the y-intercept. So it can help us find a starting point. Well, in point-slope form, it also gives us a starting point. The starting point is the x1 and the y1 coordinates. So a point that we can start with is x1, y1. Notice these are subtracted. So if we had x minus 3, that would be a positive 3 in that coordinate. Standard form is the least easy-friendly to use to graph right away from looking at it. Usually we take standard form and we change it into y equals mx plus b because it's more useful that way. But there are other ways to deal with that form. Let's take a look at some examples. Graph the lines given the equations. Notice this is y equals mx plus b format. So the first thing I do is I point out what the m and the b are. The 2 in front of the x, that's my slope. And I notice the b, which is what's added. My y-intercept is 3. So that means I'm starting at the point 0, 3 on my graph. Remember the y-axis, which goes up and down, so I start at 3 on the y-axis. Now I use the slope to tell me where the next point should be. 2 is like saying 2 over 1. So I go up 2 and over 1. Now notice I can't go any more this way because I've run off my graph patch, so I could go backwards. Well, what's backwards of 2 over 1? How about negative 2, negative 1? So down 2, left 1. And I can do that a lot of times because I have a lot of room going this way. I like to get as many points as I can so then I have a nice straight line when I finally connect the points. Remember to include arrows to show your line goes on forever. Notice this one is not slope-intercept form. This one is point-slope form. How do I know? Something subtracted from the y and something is added or subtracted from the x. So we can identify the slope. What's multiplied in front of the x, multiplied to the x? That's our slope, negative 2 over 3. The point is next to the x, next to the y, but we have to think to ourselves it's what's subtracted from those. So the point that we're going to use is negative 4, because a negative minus a negative, and we need minus there. What's subtracted is a negative, or you can just think the opposite of that sign that I see. Subtracted from the y is a 1. So that's my starting point. I find 1, 2, 3, negative 4, up 1, and there's my starting point. Now I can use my slope to help me find the next points. Down 2, 1, 2, 3 over. Down 2, 1, 2, 3 over. And I like to do that as much as I can to fill up the graph. Then I can draw my nice straight line that goes through those points, including arrows. Notice number 3 is in standard form. Standard form Sometimes we can do it by finding intercepts. Sometimes we can do it by solving for y. Sometimes we don't need to graph it and we just need to know the slope. And in that case, solving for y is the best approach. So I'm just going to practice doing it like that, since that's a way that will be most useful to us if we didn't need to graph it. I'm going to subtract the x, and when I do that, see that only 2y is left over. Those go away. Let's see. I'm going to move down here where I have more room. 2y equals, remember the x term should go first, negative x minus 4. Now we want the 2 to go away. So divide everything by 2. Dividing everything by 2 gives me y equals, this is, remember, an imaginary 1 when I don't see it, so that'll be negative 1/2 x minus 2. So now I can see my slope is negative 1/2, and my starting point, my y-intercept, is negative 2. So down 2 on the y-axis, and let's use our slope. Down 1 over 2. Down 1 over 2. I ran out of room, so let's go the other way. Up 1, left 2. Up 1, left 2. And now I can connect my points using my straight edge and connecting with arrows. Well, look at this one. Only a y. There's no x in this one. Only a y. So when it's only a y, remember we can think hoi. It's a horizontal line, horizontal, and it goes through the y-axis. So here's the y-axis. Here's the number to notice. 1, 2, 3. Here's 3. And it goes through the y-axis and it's horizontal. So I don't really have to think much. It's just a horizontal line through the y-axis, a horizontal line when it's just a y equals. How about writing the equations of lines? Well, let's look at what we have here. I need to notice a couple things to write an equation. If I want to use y equals mx plus b, remember that I have to know what's the y-intercept. If I see a y-intercept, I can use that. Well, here's a y-intercept right there, positive 1. Actually, the point is 0, 1, but we only need the y-coordinate. From there, I want to find another point on the line. Here's another point, and I can use that point to count the slope, because remember, I need the slope. So the slope from left to right, negative 2 and over 1. So negative 2 over 1, which can be simply written as negative 2. Now I can write my equation, y equals negative 2x plus 1. That wasn't too bad, right? How about this one? Well, again, if I'm thinking of y equals mx plus b, let's go locate the b, the y-intercept. I see it crosses the y-axis at 0. So our b, our y-intercept, is 0. Actually, the point is 0, 0, but the y-coordinate is 0. Now I'm going to figure out my slope from one point to another point. So let's go find a point very close. That's pretty close, the closest I can find. So I go up 1 over 1. So my slope is 1 over 1, or more simply, 1. Now I can write y equals 1x plus 0. But let's be realistic. 1 times x, we know that's just x, and anything adding 0 doesn't change the number. So y equals x is the best way to write this equation. How about this one? This is an easy one. Do you want to pause the video and see if you can get it on your own? Notice it's horizontal. Horizontal is our hoi. How do we write an equation like that? Well, it has to be a y equals, where does it cross through the graph? Here at 2. So y equals 2. That's it. I bet now that we've done that one, you can get number 8 on your own. So check it out. This one, vertical. Vertical is our vux, if you like to use that trick, Or you can just notice, hey, this guy is crossing through the x-axis. So if it crosses through the x-axis, I count to where it crosses, -3, and I write x equals -3 because the x's, no matter where I go, are always -3. So you don't have to do it the Hoy-Vux way. I just find that it can be helpful. Finally, let's do a summary. Explain how using slope-intercept form is similar to using point-slope form when graphing a line. So slope-intercept form, point-slope form. Examine those again and explain how they're similar. See you in class.